Okay, I think we will be starting with the session now. So, hi and welcome everyone. I'm Manish Nath from Hex Universe. So, first of all, I want to welcome everyone to today's session and thank you everyone for joining the session for today. So, before starting this session, I want to ask everyone that I want to see how many of you guys are really excited about today's session and want to learn more about citizen science and astronomy and definitely about its present prospect. Can you guys let me know in the chat how many guys are interested? Can you type yes if you guys are interested? Okay, I think I see a lot of people are raising their hands. They're really interested in learning about this. Okay. Okay, so I think without any further ado, we should proceed with the session. So firstly, our topic for today's session is, as I've already stated, it's about astronomy and citizen science and its present prospect. So today, to enrich us on this topic, we have none other than Gourav Banerjee with us. He is a PhD scholar of astrophysics at Christ University, Bangalore. So we are really glad to have him here with us today. So without wasting any more time, I'd like to request Gourav sir to proceed to this session. Thank you, everyone.
Yeah, thank you. Good evening and welcome to all of you. So I would like to switch off my video for good streaming, and I hope I am audible and the screen is visible, right?
Yes, sir. Both are all
Yes, sir.
fine.
Okay. So without wasting any time, let us start today's session. So welcome everyone, and first of all, thanks to SS Citizen Science Group and also Hex-Star Universe. You people are doing good work, really wonderful work, and for organizing this session, this new session today, and inviting me to deliver this talk and share my experience and my knowledge with everybody else. So thank you everyone, and thank you all the participants for joining. Let me start today's topic by some basic history. That we know that astronomy is a science, or astronomy is a subject which is as old maybe as human beings are. So when we look at the night sky at any time of our lifetime, we usually see a night sky full of stars like this if we are situated in a place where light is less. Here you can see, as there are some light pollution or light is there in the background or in the horizon region. So in this region we cannot see any stars, but above the reach, out of the reach of the light polluted area, we see a sky full of stars. So this natural beauty or natural scenic beauty of star-studded sky most probably helped humanity to progress. And just by looking at the stars, just by looking at the sky without knowing much about these objects, with what are those objects, what are those stars, it was not possible to know few thousand years ago. But just by looking at these objects and gradually reading their patterns, how these objects move in the sky, how they can actually be read and understood, to know something, some to gain some knowledge which can help humanity. This is how astronomy and gradually basic modern science began. So our today's world is very much indebted to this astronomy field, and till now we are studying astronomy to know the universe, to know about ourselves, to make our lives more comfortable. Gradually I will come to all these points. What I wanted to highlight is, astronomy is a subject which is as old as most probably human beings are. From the first day, maybe from the first time when human beings came to earth, they, due to their natural curiosity, they started looking at the sky, and that time onwards began the journey of astronomy. During those days it was the journey without knowing much, but gradually people started understanding what these stars and what these sky objects are, and how studying these sky related objects can help us, help humanity in various prospects. So one major prospect which was devised in ancient era, most probably much before Christ was born, was this concept of constellations, or concept of mapping the sky. If we can create a proper map of any place or any country, any city or any village, any outside area where which we don't know, it is easy to navigate if we have a proper map. So during those years, maybe 2000 years ago or 2500 years ago, when people used to see the sky, they understood by looking at the sky, these dots which we presently know as stars, that if we go on looking at the stars, it is possible to understand that there are few stars which are brighter than the background fainter stars. And these star patterns or these bright stars never remain at the same place for whole of the year, for whole life. It will never remain at the same place. As our earth is rotating, also revolving, as the stars are also actually moving in space, so combining all these motions, at least yearly, daily, we see there is a motion of stars in the sky. Also there is a motion of planets and sun and moon. So by reading or by understanding the patterns how these celestial objects move, people were able to create the first map. And the first map was made for sky, not for our earth. So this kind of mapping involved joining imaginary lines with some bright stars which looked bright to some people in some place of the earth, and making these imaginary patterns which either look like some objects, some familiar objects, some familiar animals, human beings, some familiar type of animals like this. So this is how the sky got gradually divided presently into 88 patterns. And these patterns of imaginary lines connecting bright stars are known as constellations. So if we look into this particular patch of the sky, we see there are the imaginary lines have been connected to the stars, and these are some of the very prominent constellations of the winter sky. Present winter sky is not possible to see, but when we come to around October, November onwards, we will see a sky full of these stars. If we can actually identify, as I have already told, that these are imaginary patterns, it is not easy to identify, but just by looking at this particular shape or this particular pattern, one might think it is a quadrilateral, one might think it is something else, one might think it is an animal. These are all imaginary understandings. But this patterning of the sky helped us, or making constellations in the sky, in the celestial sphere of the sky, helped us to make a map of the sky and to understand how to navigate, how can we predict seasons, how can we predict what kind of seasons are coming, where we can cultivate, where we can do agriculture. These were the basic necessities of human beings when humanity was in infancy. So but if we instead of just joining these patterns, if we try to see the same patch of the sky with the figures, then we will see that these are some prominent constellations, and these are the imaginary patterns which were imagined by those people, ancient people, which we also trust and which we have also adopted now. It has nothing to say, or this is nothing mandatory to understand or feel, that when we look at this particular pattern of stars, it actually looks like a Orion or a hunter, celestial hunter. Or when we look at this portion, it actually looks like a flying horse. It is not actually the case. But as this is a tradition continuing for thousands of years, we have accepted that mapping the sky is done by this way. And we have accepted that the sky is presently divided into 88 constellations having 88 patterns. So, this first mapping of the sky, which helped humanity to progress, not only progress in science or particularly technology, progress in life, their basic necessity of navigation, agriculture, making proper ritual timings, calendars, these all depended on sky. And from that day onwards, thousands of years have passed. And through the help of so many great people, so many great philosophers, scientists, astronomers, various people who have at least once in their lifetime worked with objects or worked for the understanding of the universe or the sky or the cosmos, we have come to know so many things. I am definitely sure that these three people are well known to everybody, whoever is listening to this talk today. Kepler, Copernicus, and Galileo. We call them as the as Stephen Hawking has called them. They are the giants. So we are all standing on these giants, and we are doing our work today to understand the universe more and more. So these people were the pathfinders, or these people laid the foundations of modern astronomy, modern science, modern physics, and many other things. So with the help of these people, ultimately, I will come to a point in 1608. So it's around 2000 years later from the day of first understanding of constellations, patterns, mapping of sky. Now we are in almost in a medieval period of our Earth's history, 1608, when the first telescope, the first proper instrument, proper machine to understand the cosmos or sky was invented. I have to mention here, yes, my friends, th- there are many people, or there are also even misconceptions in many places, that Galileo Galilei was the inventor of the telescope. This is not the case. Galileo Galilei was the first person who used his telescope to look at the sky, and that is why his contributions are important, very, very important. He is truly regarded as the father of modern science. But telescope was not invented by Galileo. It was invented by another person who was not at all a scientist. He was a glass maker, spectacle maker of Holland, Netherlands. So his name was Hans Lippershey, and the patent of telescope is filed for him with his name. So he was the person in 1608 who first invented a machine or an instrument which we presently call as telescope. From that day onwards, we have come a long way. And present day, when we see telescopes are of different types, majorly of two types, without going to details of these optical telescope systems and designs, presently we have very sophisticated telescopes which can even be used by amateurs. Anybody can buy it, anybody can use these instruments to look at the sky, to study the sky. There are also binoculars, different types of binoculars, so we can study the sky, and we can look at the beauty of the sky in deeper details with the help of these kind of instruments, provided if we know how to look at the sky and if we have a basic understanding about the sky watching and techniques of sky watching, these things. But we have to understand that ultimately these are definitely much, much more advanced telescopes compared to those first telescopes produced by Galileo, Kepler, Hans Lippershey 400 years ago. These telescopes are much, much more advanced, but we have to understand these are basically amateur telescopes. These are telescopes which anybody can buy and look at the sky for enjoyment purpose, for fun purpose, also for basic study purpose. But these telescopes cannot be used for serious research until few years before. These telescopes cannot be used for 100% serious research. So for 100% serious research, professional astronomers use different types of telescopes. To give an example, with the telescopes which I was talking about, if we look at the sky, very familiar objects, moon, Jupiter with its four moons, Saturn with its rings, Mars, Neptune, Venus in its phase, proper crescent phase. So these are the objects, or these are familiar objects which we can see with the help of these amateur telescopes. And this is how the telescope views with proper filters, proper other instruments, eyepieces. These are how the objects of our familiarity looks like with a proper 8-inch or 6-inch telescope from a good sky, good clear sky. Now, just by looking at these images, we cannot tell anything about the science behind these images, right? So, for understanding the science, if I want to ask why the moon's color is like this, just by looking at this image, we cannot tell that. So, for understanding why moon's color is like this, we have to go for professional astronomy research. And for professional astronomy, such small telescopes are barely used nowadays. For professional astronomy, there are professional telescopes, very big, very top class, sophisticated technology is used for these telescopes, and the places where these professional telescopes are situated are known as observatories, or in general astronomical observatories. So in these are some of the greatest great observatories, the first three images, great observatories in various parts of the world. The last image is of an observatory with the largest telescope, which is gradually coming up. The proposal is already sanctioned. There are some preliminary works have started. This is known as 30-meter telescope. I am not going to any other specifications. So this is going to be the largest telescope in the world, and it is a good news for us that India is also a partner for making this telescope and running this facility. Apart from these telescopes, definitely being an Indian, we Indians do have top class telescope on observatory facilities in India too. One of the best places in earth where one of the greatest astronomical observatory or telescopes are situated in is in India. It is a remote place known as Hanle, which is in Ladakh. So if you want to go to this place, you have this magnificent beautiful view of the Himachal Pradesh, this Karakoram range and great Himalayas of Himachal Pradesh, Dhauladhar range and all these things. So you have to go from Leh. So this is the Leh airport. You can carry on your journey through a place, and I feel you can understand just by looking at the road. This road goes to this particular place known as Hanle, where Indian Astronomical Observatory is situated. So this place is devoid of any kind of light pollution. You can understand no person, no civilian lives here. It is a cold desert. It's a very barren land, and that is why, as there is no light pollution, it, there is no other kinds of pollution. It is a wonderful place for an astronomical observatory, and that is why if we go gradually, you see the sky is gradually becoming clearer and clearer, crystal clear sky. And ultimately, when you reach this place, this is the Indian Astronomical Observatory. Very recently, this Hanle Observatory has been declared, or the nearby places of Hanle has been declared as the first dark sky reserve of India, where dark sky will be prevented by law in India. So this is one of the most fantastic and most sacred, I will say, most holy places for astronomers in India who does observational astronomy research in India. So one of my major work during my PhD was also related to data coming from this particular telescope, which is a major indigenous effort and successful effort of India. Apart from this, we also have other wonderful facilities in our country. This place, Kavalur, so this is known as VBO, that is Vainu Bappu Observatory. It is located in a village, near a village known as Kavalur, and this is basically, we can call it as a telescope town of our country, of India. You see, this is a fully forested area. It is a place located in Tamil Nadu, fully forested area, and so many telescopes you can see here. So many telescopes at this particular observatory are located here. It's a very historical place. So many historical discoveries have been made by using these telescopes. So for example, you see, this is one of the oldest telescope in our country of this structure. It is a huge structure. These telescopes are basically huge. These are not amateur telescopes, as you can understand now. You see people standing here. So these are very huge structures, and they are capable of watching the universe in a different way, definitely in a better way. So this is the famous historical 40-inch 1-meter telescope at Kavalur Observatory. To give an information, rings of Uranus. Yes, my friends, Uranus, Neptune, and Jupiter also has rings. They are very faint. It is not observable using simple telescope from our Earth. So rings of Uranus was first discovered by the help of this particular 40-inch telescope in India, sitting at India. So this is why I was telling that India presently has different world class facilities doing major works in astronomy research, and India is presently one of the leading spacefaring nations, of the leading astronomy powers in the world. I will come to that point later. Just to give a flavor, I have added these few slides here. So this is why this tells us that we people, we are already situated in a golden time of astronomy, not only in India, in the world. Because not only in our earth, not only in our surface, we have wonderful telescope facilities above the Earth's atmosphere. For example, HST, Hubble Space Telescope, which is known to almost everybody. This is a telescope which is situated above Earth's atmosphere, so there is no light pollution, no kind of pollution can hamper its observations, no cloud, no light, no rain, nothing. And very recently, 2 years ago, around 2 years ago, we know that James Webb Space Telescope, the successor for this particular telescope, has gone to space. So there are certain amount of very high powerful, sophisticated telescopes working in space also. So this is a time when we are situated. This time is luckily or fortunately, we are situated in a time which we can tell as golden era or golden period of astronomy, and that is why shouldn't we take that opportunity? If we are standing on a golden era, then can't we do something on astronomy? Can't we do some kind of studies, or can we involve ourselves in astronomy, either by studies or outreach or research somehow? So yes, we can. And as I have mentioned, that India is also a major player in astronomy research in India, in the world presently. Apart from that, our knowledge has shown that just by the telescopes which I have shown you, just by using a particular type of telescopes like that, we cannot know the universe fully. Why? Because what is light? Basically, light is a type of radiation. Light is a form of energy, and this form of energy, this what we call as light, is a form of energy expanding from a huge stretch, belonging to a huge stretch of energy range. Now, among that radiation range, only a very few amount of radiation our eyes or human eyes can detect. So if this is the full electromagnetic spectrum or the light range of where light in which light belongs, there are different types of light. Out of this whole electromagnetic range, our eyes, human eyes, can only detect this much amount of energy lying from this level to this region. And this energy or this electromagnetic radiation which our eyes can detect, we call it as visible light, drishyo alo, visible light. But apart from this visible light, we see that in that same electromagnetic range or energy range, there are so many other forms of energy. Electromagnetic energies of different other energy levels also exist. So what about that? That means light, as we see or as we know very simply, is not what actually we see is absolute light. So our general light which we can perceive or which our eyes can see is known as visible light. But in the whole electromagnetic spectrum, other kinds of light also exist which our eyes cannot detect. For example, infrared, microwave, ultraviolet, gamma ray, x-ray, these all terms which might be known to many of you are actually forms of light or electromagnetic spectrum or energy radiation. And this whole radiation range is known as light. So if our telescopes or if our eyes are only susceptible or only they can detect visible light, that means we can only, out of this whole range, our telescopes can only detect this much of the light. So in that case, can we know everything about universe just by detecting so little amount of light? That means we are missing information. If we can devise telescopes which can detect not visible light but the hidden forms of unseen light, like microwave or ultraviolet energy or gamma rays, x-rays, infrared, if we have telescopes for detecting these hidden light or hidden electromagnetic spectrum, then only we will see a universe in a different scale, in a different way. For example, just come to this picture. The second picture, this is a picture of sun. The second picture is very well known to us. This is the picture of sun taken with the optical telescope, the telescopes which I was talking about. And how sun looks like, very calm and quiet, no activity. But we know that sun is a burning ball of gas. So where is that burning ball of gas kind of feeling? Nothing is coming here. That means we can become nature tends to make us fool. We can be fooled if we only try to see nature with limited knowledge or with limited specification. If the same sun we see with the help of an infrared telescope, the first pictures is the same sun seen with the help of an infrared telescopes which can detect infrared radiation. We see it feels that okay, now sun is looking like something at least not burning, but at least fire. Is very energetic. It's looking completely different as we see in optical light. Now come to the third and fourth pictures. With the help of an ultraviolet telescope, how sun looks like, third picture, and with the help of an X-ray telescope, the real sun actually reveals. And we see that actually sun is a burning ball of gas, burning flames of matter is actually coming out from sun. So this is how the very basics, the very familiar, the very nearby star of us reveals itself properly if we can see it or if we can study it using not only limited knowledge but with the whole knowledge which exists in the universe or with the whole information. And for understanding, for getting whole information, we have different types of sophisticated telescopes presently. Different places of earth has it. In our India also we have. Our India is boosting. It is our pride that India has one of the most important and most powerful radio telescope system in specifically meter wavelength area. So this is known as meter wave radio telescope, GMRT, located in a place near to Pune, India. You see these are antennas, so many antennas, and covering a whole area of around 25 square kilometer. There are so many like this kind of so many antennas are placed, and combining each and every antenna is basically a radio telescope. So a radio telescope now doesn't look like a familiar telescope as I was talking about, and that is what I wanted to point out. Presently astronomy is has expanded many folds. We are not limited to only observing the sky with optical light. Instead, we are observing the sky with the help of every kind of other light or radiation which is available. We have telescopes in every aspect: radio, microwave, X ray, gamma ray, everything is there. So that is why our knowledge is increasing and huge amount of data is coming. Now, what we need are astronomers, and also we need is the help of common people also. So many facilities are there, so much of amount of data is coming, but the amount of astronomers or the amount of astronomy researchers in India or outside India also, in the whole world, is much lesser compared to what we need. So through the help of these telescopes, through the help of this journey of humanity, what we have learned is huge. It's astounding. First, we have learned about our own solar system. I will not go to the details of these particular solar system objects and everything. We have also known or we have come to know about our bigger home. If we say that our home is solar system, if someone asks the solar system that what is your home, where the solar system is situated, that is situated in a bigger home which we call as a galaxy. So as a galaxy is a that galaxy is a conglomeration or a system of huge number of infinite number of stars, planets, nebula, gas, dust, everything conglomerated together. So this is the galaxy where we live in. This is how our galaxy basically looks like. Our galaxy's name is Milky Way, as most of you know. And this galaxy, is it a single galaxy in the universe? Our knowledge about astronomy and space has told no, it is not. In our own galaxy, we have several beautiful sites to look into. There are so many clusters of stars. Each and every dot in these all pictures you see are actually stars, and all these stars and star clusters belong to our own galaxy. There are around more than 10,000 crore stars in our own galaxy. One of them is our sun, very simple star. Apart from these star clusters, as I have told, there are huge blocks and chunks of interstellar gas and cloud, which are known as nebula. So these interstellar gas and blocks of gas and interstellar dust and glass, some of these nebula are also the places where stars form. Some of these nebula act like stellar nurseries. So that is why in fantastically we can say that many of these nebula are known as stellar nurseries. They are really wonderful. The structure is beautiful, and before the telescope era, it was impossible to see these kind of structures. If we go beyond our galaxy, we have come across a lot of galaxies, innumerable number of galaxies we have studied, different shapes, different sizes. They are located almost in everywhere. If we see, wherever you point your good telescope, you will see galaxies. Universe filled of galaxies, stars, and everything. Such vast is our universe that are we are numbstruck, and that is why we need to know them. Just only in this picture, if I ask that, okay, can you particularly say that all these 6 7 galaxies you are watching are the same, are they looking same? No, only pictures of galaxies I am showing, and there are innumerable, everything having a particular shape, size, feature, characteristics, properties which we need to know. And that is why this is a basic importance why we should study astronomy, to know about the universe, to know about the how nature works. And universe is the best place or best example or best laboratory where we can study natural objects apart from our earth. So this is why studying astronomy is important, to know how nature works. And as universe is very very huge, having so many stars, galaxies, and other examples, so that is why we can study so many types of objects. And universe gives us the opportunity to study the most extreme laboratory. Such objects, such properties cannot be found in our own earth. To understand scientific knowledge, we have to study different types of objects with different types of properties. And that extreme laboratory, the best extreme laboratory, exists in space, not in our earth. Apart from that, our own lives can become comfortable, more comfortable, if we study astronomy. And if you want to know about ourselves, our own home, our existence, how we came, our origin, we also have to know about the astronomy. This seems very odd. Okay, if we want to make our own lives comfortable, what is the necessity to study stars? But it is true. We have to know about ourselves. If we want to know about our life, our history, we have to study astronomy. So let us come to few examples. I have told that astronomy gives us the best laboratory, the best, most extreme laboratory. Why? Okay, let's start with this one example. Give one example. What is the largest star which we know till now, conformly? So just look at this picture of sun. It is our nearest star, and as I have told, it is a very simple star. It is not very large, not very small. It is a mediocre star. There are so many stars in the universe, innumerable. Then which is the largest star? To give an idea, as I have told, that sun is basically a burning ball of gas. Yes, it is. It is a burning ball of gas. This shows an X-ray imagography where you can actually see that huge flares of fire is coming out from sun. If if we can take an image of any of this flare which has been done in this picture, one flare of, or one solar flare, or one burning flame of gas from sun has been imaged here. And if we put our earth in front of that burning ball of gas or burning solar flare, see, this is the size of earth. So this was a picture of 1999 when I was very young. So only one flame of fire coming out of sun is so huge compared to whole earth. Can you understand? Can you imagine how big our own sun is compared to earth? It is very, very big. It is very, very big. So more than 13 lakh Earths can fit inside one sun. This is how so big our sun is. But compared to other stars, sun is not at all a very big star. It is a mediocre star. So if you want to know which is the largest known star in the universe till now, then this is the star. Bit odd name, NML Cygni. And if we put in front of this star, if we put our sun, then sun looks like this. It's so big that 700 crore suns will fit inside only one star. I feel this small example is enough to give an understanding why I told that space or astronomy provides us with the best laboratory. The most extreme laboratory is space. In every aspect, we get most extreme examples not sitting inside Earth, but looking outside Earth. I have also told that universe is huge. Yes, definitely. You see this picture. How huge is the universe? Definitely very, very huge. Just to give an example, look at this picture. This is a picture of a patch of the sky which is very small. How small? This is 1 degree by 1 degree. So if you try to draw an angle with your protector, a 1 degree angle, you can understand is very, very small. An area which is so small which can fit at the top of your pencil head. So that small patch of sky was pictured by Hubble Space Telescope, and we see these things. So many stars, there are maybe some galaxies also. But in this picture patch, there are also patches of dark sky, patches which are dark, apparently dark. For example, this one. You see, this patch looks apparently dark compared to these areas. What is there inside this patch? Is this a vacant void? Nothing is there. These are very far away images. So what scientists did? Scientists commanded Hubble Space Telescope to point its camera to point the telescope towards this dark patch and took a picture of this place. This patch of light or this patch of area is much smaller than this one. It is 1 minute by 1 minute. Just think, just think, or just imagine to try to draw an angle of 1 minute. It's almost impossible with any normal protector machine or any normal geometric machine. So it's so small. So it is the size what is available at the top of a safety pin. That much small patch of light or small patch of area of the sky was pictured by Hubble Space Telescope, and what we found was just mind blowing. That apparently dark place contains 5,500 galaxies, very, very far away from us. Most probably more than 1,000 crore light years away from us. So basically, you can understand, you can get a feeling how big the universe is. It is actually tremendously big. And that is why it is tremendously big. It is full of so many types of objects which we don't know. And we have to know them to know how nature works. And definitely to make our lives also more comfortable. How our lives become more comfortable by studying a galaxy or a star. So this is, I feel, is the most famous and most easy to cite example. We all know that these three great people went to moon for the first time in the human history. Armstrong and his two friends. It was 1969. So for developing, I am not presently concentrating on the story of how they went to moon, but I am concentrating how they developed. What help we received by sending three people to moon. Let us see now. This sending people to moon was not a fancy of people just wasting money. No, not at all. For developing Apollo missions, which actually carried human beings to moon, scientists has to develop or discover or invent so many other kinds of new technologies, new scientific knowledge was gained, new scientific innovations were made. And presently, many of such innovations we are using without knowing. For example, so only for sending man to moon, Apollo mission, what Apollo mission gave every people is this. Have you heard of insulation? Have you heard of water purification process? I feel in Calcutta or in big cities of India, and maybe, I don't know, maybe in other countries also, almost every home nowadays have these aquaguard water purifiers. Now, how many of you know that water purification process was invented for developing Apollo mission? How many of you know that gas analysis, programmable pacemaker, dialysis machine, kidney, especially improved version of kidney dialysis machine, then deep freeze system, all these things were invented for Apollo missions at first. And presently, we use that. Then there are so many other aspects which I can go on telling. You can go through some good books and other into internet sources. You will get to know so many other things. So basically, space or venturing space is not a fantasy as many people generally believe or think without knowing about space, or without knowing or without understanding how space basically benefits at present every human being in earth. Not a single human being can claim that I am not benefited by space. Not a single human being. This is just a very small example of that. And apart from that, I have also told that to know ourselves, we have to know about space. Almost in every of my talk, I show this slide. So many of you might be familiar with this. You see four pictures in this slide having completely four different views. So my question is, there are so many things, so many different type of items which is visible in this picture. Can you say only one thing which can connect all the items which you see here? Only one thing exists which connects everything what you see here. Everything. I will give the answer for today. That only one thing is the stars in the night sky. How? It's amazing to believe, it's amazing to just even imagine. If we look into the periodic table, that is a table or a scientific table which tells us the properties of all the elements which have been discovered or which have been found in earth, either naturally or man-made. So basically, our earth and everything outside earth, the whole universe is made up of matter which is made up of any of these elements, either hydrogen or helium, or carbon, neon, oxygen, sulfur. There are so many elements, more than 100 elements. And our, our whole universe, whatever you see in this universe, are made up of by the combination of these elements. And how many of you know that apart, so there are more than 100 known elements. And out of these 100 known elements, more than 100 elements, only hydrogen, the first and the lightest element, a major portion of helium, and a very little amount of lithium. Apart from these three, all other elements you see here are once produced inside stars, inside some long blasted or long dead stars. How stars can produce elements, that is a long different story, that can be a complete different talk, or a complete, I will suggest complete different coursework. So that I am not going details into, but this is true that whatever we see in this universe, apart from hydrogen and helium and very little amount of lithium, everything, every element was once produced inside the core of the stars. And that is why when you drink any of these things, even a cup of water, a glass of water, or whatever you drink, whatever you eat, so if you look what these bone vita or what this Horlicks is made up of, just see the behind part, nutrition facts of Horlicks. You see iron, vitamin A, zinc, iodine, calcium. These are all elements, these are everything which has been produced by stars once. And the companies are making it properly packed and they are serving it. So basically, when we drink any of these things, even a cup of water, we are actually drinking a part of the universe, a part of the stars. These are actually cosmic soups, and that is why Carl Sagan, one of the famous astronomers, he correctly pointed out that every child who is born in the earth, in the whole history of humanity, every child is basically a child of a star. We are star childs. Our life, and we are very much connected to stars and the universe. Not astrologically. It's not the fact that if you do not read and wear something, a ring or something, then you will become fast. That is not the case. But our life is definitely very much connected to stars. And if we want to know about our life as a whole, our humanity as a whole, how we came from, how we emerged, then we have to know about astronomy. And this is why these are some very few examples why we should study astronomy. And that is why astronomy is progressing very heavily nowadays. So, as I have mentioned, that our India, we know that very few, just 10 days ago, just 2 weeks, 1.5 week ago, India has launched Chandrayaan 3, the third Chandra mission or lunar mission. So, this is, if it becomes successful, which we hope so, this is going to become one of the major success of Indian space research program. Now, today we are watching this, but if we go to the history how Indian space research program started, I have just jotted down a very few points here. So it's a long history and it's an incredibly fascinating history. We started from almost nothing, almost zero. We started from zero. And presently, India is one of the space powers of our country. So 1962 was the time when there was a committee which decided that we have to form some space research program in India, which ultimately culminated in 1969, 15th August, where Indian Space Research Organization, that is ISRO, was established. So, without going into much details how ISRO was formed or the story of Indian space journey, I can suggest that if anyone wants to like to know about this thrilling journey from zero to the one of the greatest space nations in the world, how India became, you can read any of these two books. One book, this second book is a fantastic historical account of how India became a space power from starting from zero, and the first book deals with a fantastic topic, how almost every Indian human being, almost every Indian citizen is benefited by whatever has been done by ISRO, especially by Indian research program, Indian space research program. These are all easily available books in Amazon also. You can search and go and have a read. So let me now give a glimpse that if any one of you, I am sure that many of you are young listeners today, how to become an astronomer. I am talking about astronomy is important. It is important to study astronomy. It is fascinating also. But how to become an astronomer? In a very short note, I will just give you a basic idea. Ki after your class 12 standard, after class 12, definitely you have to go with pure science stream. I am not highlighting each and every stream now because from this year onwards there will be a change of syllabus and pattern. So maybe after 2 3 months we will be able to make these slides much more better. So basically you have to go with pure science stream with physics, mathematics, chemistry as much as possible. You have to have very good command in physics and mathematics and also computer science. Basically nowadays computer dominates the world, and astronomy is definitely dominated by computers and programming languages. Any one programming language, if you know, that will be very helpful for you. So presently we astronomers, we personally like Python programming the best because it is very easy and is very user friendly. So that's why I have written Python programming language is knowledge is important for the time being. But any programming knowledge will help you definitely. Understanding, reading skill, listening skill, fluency in English, writing skill, patience. These are some very useful key aspects, or this what we call as soft skills, which you have to develop gradually because research in astronomy deals with intense amount of reading, listening, writing and speaking. So you need to know all these things. You have to become a skilled person in these four aspects: writing, reading, listening, and speaking. So, because if you don't do that, how will you express what research you are doing, what you are doing? You have to express it by reading, by writing papers, by writing documents. You have to express that in the community by speaking, by talks. So also you have to learn, and for learning you need patience to read so much of reading, continuous reading. So just in my 4 years of PhD, I have read more than 1,000 research papers only on my particular topic, apart from other things. I have done so many other things. I have been involved in enjoyment, watching movies, science outreach, public outreach, going to camps, sleeping, dancing, so many things. But apart from that, that you have to understand, you have to decide how you will manage your time. I am just giving an example. I am a very normal, simple PhD researcher, but I had to read more than 1,000 research papers within 4 years to complete my PhD, only on my specific topic. And apart from that, you have to gain a very good understanding about basic astronomy, all aspects of astronomy. That will help. Definitely, that will help. So after 12, yes, these are, so you go ahead with BSc or BS, whatever it is, or dual degree. Now this year onwards, there will be a change in all these aspects. So graduation with physics, you need to do graduation with physics, or in some aspects, you can also take BTech degree, BTech in space engineering, BTech in space science. From this year onwards, IIT Indore has started one wonderful course, which is BTech in space engineering. So, but we will update that maybe after a few months. Let this course begin, let this syllabus settle down. So that's why it's a very basic slide. Yes, you have to go to graduation with physics as major, or if not, then space engineering, if you are going to engineering area. So this is one of the greatest place of science research in India. That's why I have put the picture. You can call it as a temple of science research, Indian Institute of Science, IISc. Here also you can go for BS or graduation degree. And after your graduation, what you will do? You have to go with master's degree. Master's degree either in physics or in astronomy, astrophysics. So there are places where masters in astronomy and astrophysics in India is offered, like Osmania University, IIT Indore. In Kolkata, from the previous year, I guess previous year onwards, Kolkata Presidency University has also started a department of astrophysics where master in astronomy, astrophysics is offered. And else you can, there are some, maybe within next 1 year, some more universities are coming up. So this is a wonderful time where universities are also thinking about launching new courses for astronomy in India. So we are actually in a very good opportunate time. We are situated in a time where astronomy is progressing rapidly. So masters in physics and astronomy, after you complete this masters, you come to the actual stage where you have to go for astronomy research. So basically, this is the time when you go for PhD in astronomy. This is the time when you get involved in actual astronomy research, proper, serious, actual astronomy research, which is very hard and which is very fascinating, very interesting if you are interested. So for PhD in astronomy, yes, these are some of the exams: JEST, NET, GATE. These are some of the qualifying exams. I have given one name. JEST is a prominent exam for qualifying for PhD in astronomy in some of the reputed research institutions of India dedicated to science research or astronomy. So one can go to this particular website and see which are the research institutes or which are offering, which take students in PhD in astronomy astrophysics using JEST score. So I feel this might become more heavy if I go on detailing how can you become an astronomer in one talk like this. So if suppose any one of you are interested, you can go through internet also. Apart from these well-known institutes which are dedicated to astronomy research, there are also some particular good universities in India, like Christ University, Bangalore, where I belong from. They are also offering different courses in physics, and this is also a prominent university presently in astronomy research in India. And there are other universities which are gradually emerging. That is a good sign in our country. If you want to know in detail that how can I become an astronomer, how what I should do, step by step guide to become an astronomer, then one can look into this particular book which is available in Flipkart or Amazon. This is exactly the way what I have told is exactly this is the book which you can go through. This is the a friendly guide which tells the details how an Indian, basically an Indian student, can become an astronomer right from class 10 onwards, what to do, how to follow, and what are the institutes. Everything is detailed here. So let me now come to the major aspect. Well, when we all are in this phase of time where astronomy, we are in the astronomy golden age of astronomy, India is progressing, how we can contribute in astronomy if suppose you are not a professional astronomer, if you are already aged, if you are already a housewife, if you are already a child, you are not in class or PhD level or MSc level, then without going to MSc level, can't you contribute in astronomy? Yes, you can. Up to a certain level, you can definitely contribute in astronomy. And that is why the concept of this thing came, which is known as citizen science. Before going to details, I would like to tell that if you look into the history of astronomy, you will see there are so many people, so many great astronomers whom we know. They were not basically professional astronomers, they were amateurs, including Copernicus, including Galileo. They were not professional astronomers. So astronomy is a rare field where amateurs can actually contribute, highly contribute in really a good way. How? Nowadays, the platform for contributing in astronomy, being an amateur, is through citizen science projects. So, what is citizen science? Citizen science is a type of platform, or citizen science are projects which are dedicated for any citizen of the world who is interested in a particular subject, and they can become a member of that project. They can learn about that subject and contribute. For astronomy, one can go to this particular website, zooniverse.org, and here you will see one by one in every area. You will see different citizen science projects have been uploaded. See, if you want to do some citizen science project in medicine without being a doctor, you can contribute, but you cannot tell yourself a doctor. Please remember that. Otherwise, you will go to jail. So, or you can call yourself you can contribute in any other field like physics, like science, but you cannot call yourself a scientist. Then it is wrong. So in astronomy also, presently there are more than 20 projects running, which are citizen science projects. Any of you can go to this particular website, scroll here, you will see space, click it, and you will see the projects. You can join any one project. See, this is a particular project on sun. This is a particular project on classification of galaxies. This is a particular project to search for aliens. Well, this is a particular project, I suppose, Gaia. So that means it's definitely related to stars. So like this, there are so many projects available in this platform for astronomy, where you can go, no background, no training, no expertise, nothing is required, no money is required. You just need to have internet and a laptop or a computer. So to give an example how it works, okay, this is one particular project, Disk Detective. What is it? So here basically if you want to become a member of Disk Detective, you have to get started with it. You have to click this and become a member, read about what this project is and how you can contribute. Everything is there. And then you can start contributing. What this project does, this particular project is to study and detect the disks. There are so many stars which has disks around them, dusty disks, gaseous disks. So these particular stars detect particularly dusty disks around young stars. And this study is important. Studying young stars and their dusty disks can tell us how our solar system formed. So that is why we need to study We need to detect disks around other young stars, and we need to study them. But for studying, there are so many stars, right? So there is already a mission which is known as WISE mission, which is surveying the whole sky in infrared. And it has already detected so many dust disks around young stars. You can help in finding these dusty debris disks using your knowledge, which you can gain by reading the documentation here itself. Nothing, no background is necessary. No age, no money, no background, no expertise, nothing. If you are interested to contribute to astronomy research up to a certain level without being an astronomer, this is a wonderful project, wonderful, nice project where you can help astronomers find and discover dusty disks around young stars. And the data is coming from a particular proper NASA space satellite. So, not only that, if suppose from that same particular project you see a research paper, Astrophysical Journal is a wonderful high level research journal in astrophysics. You see papers have been published using the data or using the knowledge or using the discoveries given by amateur astronomers. So in this particular paper, you see there are 14 authors, and from these onwards, 8 among these 14 authors are amateur astronomers, disk detective citizen scientists. So anyone who joins a citizen science project is generally termed as citizen scientists. They are basically amateurs. But if your contribution is considered a substantial contribution, then you might become a co-author in a major research paper in a major journal. And contribution, by the word contribution in the field of research, we mean the highest form of contribution can come if you have a research paper, published research paper. If it is a co-author, very good. If it is a first author, well, that can only be given by professional astronomers or professional researchers. So by contribution, we only mean in research, by contribution, we only mean proper research papers in authenticated, properly indexed journals. And this journal is one of the fantastic, one of the topmost journals in astrophysics. So if you can go on contributing, you can also see your name one day in such a research paper. Has it been done till yet? Yes, it is. You can go to this website. So many research papers have been published by the contributions of citizen scientists. And this is a website where the list of all citizens, all published papers using citizen scientist data or knowledge has been listed by NASA. So you can go to this website and see what are the papers in every area which are published using the knowledge taken from citizen scientists, using the contributions of citizen scientists. In India, is it going on? Presently, there are so many projects in citizen science in so many places in platforms running. One very famous project is this, searching for new asteroids. It is important to search new asteroids because there are so many asteroids we know, and so many asteroids we are sure we don't know. It has not been detected. And we are definitely sure that some of the asteroids crisscross their paths while traveling or while revolving sun, crisscross their paths with our orbit, Earth's orbit. So if suppose suddenly one day an unknown asteroid hits Earth, what will happen? Mass devastation. This has happened with Earth previously also. We presently have certain understanding that dinosaurs got completely vanished or completely extinct because of a sudden hit of an asteroid around 6.5 crore years ago. So what if another asteroid hits today, now? Then we will be finished. So that means it is important to track and detect asteroids, new and new asteroids. Almost every asteroid which is present in our solar system, if possible, if we can detect and predict the trajectory of all the asteroids, then we can make our home safe. It is very difficult task. And that is why presently we do not have so many astronomers in the whole world who can only look into asteroids. That is why there is a huge citizen science project known as International Astronomical Search Collaboration. You can go here, you can become a member of this, and you can start searching asteroids, being anybody, being a student, being a general person, whoever it is. From India, the first people of India who actually detected, who actually discovered an asteroid were actually two school boys, class 11 boys from Delhi Public School, Delhi. It was in 2011. You can go to this particular news, you can see this. These were the two boys. So it's not that always you have to become an astronomer or scientist to do something good in astronomy. And presently, surprising that presently we have come a long way. I was talking about 2011. Now you see 2023. I am giving an example from our own West Bengal, and I am sure that in almost every state these kind of examples are there. See, this is Shaurjo Pal, class 6 student, 11 years old. He has already identified 5 asteroids, and it came to the newspaper. So this is happening. It's actually happening. It's on April 3rd, 2023, Uttarbanga Sangbad. So it's happening. So we have come a long way within the past 10, 20 years. And there are ample amount of scope you can contribute by doing astronomy without being an astronomer. I am proud to say that the youngest citizen scientist in NASA is an Indian and a Bengali from Kolkata. This is the boy, Arush Nashkar. He is a class 4 student. He's a class 4 student, and he has also helped in identifying 5 asteroids. See, if these small kids can do something good, can't we all do something good? Yes, we can. If you are interested in astronomy and space, you can, instead of just taking photos of space, instead of just looking at the sky for whole day and whole night, you can actually contribute nowadays. That is what I wanted to point out in today's talk. But for contributing, there should be something Indian, right? So this is the first Indian citizen science project. It deals with radio astronomy. If anyone wants to join this project, you can go to Facebook, this particular page. I guess this talk will remain in YouTube, so you can see later also. So this page, you can join this page, contact them, and you can become a member of this particular group and do astronomy research or help in radio astronomy research. But for some basic guidance, there is a WhatsApp group presently, which is a dedicated WhatsApp citizen science group in India. And they are basically citizen science group dealing with astronomy projects. So this is the group. Many of you know that, I am sure, SA Citizen Science Group. If you don't know, you can just send a message to this WhatsApp number or just go through this website. This is their website. So you can become a member of this WhatsApp group. No, nothing is required. And you can ultimately gradually come to know how members of this group are contributing in citizen science projects in different ways. So this Arush and they are all members of this group, and you can also become a next member. Presently, this is the largest Indian citizen science group in WhatsApp. It has over 3,000 volunteers. It has over 250 members. It is spread across almost, I guess, all the states of India, and it is giving guidance in more than 20 different citizen science astronomy projects. So you can become a member of this group. And some of the members of this group I have already highlighted. There is no gender bias. You can see that every gender, every caste, every religion, they can become members. They are already producing good work. You see in this particular notification where 132 citizen astronomers have been named who have discovered or who have classified more than 1,000 galaxies. They have been given honor, and among them you see so many Indian names, so many Indian names. They are all citizen scientists, and they are mostly all of them are, I guess, in this group. They are all members of this group. So you can also become a member of this group. You can do, and you can ultimately, if you can substantially give really good contributions, you can even become a co-author in a published paper. So this monthly notices of the Royal Astronomical Society, this is again one of the topmost and the oldest surviving proper astronomy journal in the world. It's one of the topmost, most prestigious journal. So you see, they published a paper in 2022 June, and you see this person, Shobhan Acharya, who is also the founder of the Citizen Science Group. He was declared, he was taken as a co-author. He was given this honor to become a co-author of this paper, considering his substantial contribution, important contribution. So this can happen. So basically nowadays, presently sitting in India, any place, wherever you are, if you have the desire and if you have a very basic facility of having internet and a computer, you can contribute in astronomy. You can get guidance in astronomy. You need not have to personally go to some particular place or institute to start learning about astronomy. Internet presently is there, and there are WhatsApp. There are so many aspects. I have just mentioned about very few here, and I know as time is almost more than 10 minutes I have taken, I will stop here, but ready to take questions, and maybe gradually this can continue. Thank you, everybody.
Thank you, sir, for this wonderful presentation. Now I think we can move on to our Q&A session for today. So participants, if you have any questions, please feel free to ask your questions by turning on your mic, or you can also ask your questions by writing in the chat, and I will be reading out the questions.
Sir, namaste, Gaurav sir. It was fantastic session. You brought us from ancient to present day science.
Hello, Vijay.
Really wonderful.
Yeah. Thank you.
Really exemplary one, sir. Fantastic session. Really, I loved it.
Thank you very much.
Hello, sir. I am Rudra Nandi. I am from Bangladesh. Take love from Bangladesh. It's a great
Hello.
session. Hello,
Hello,
sir.
Rudra. Hello.
I'm
Hello, Rudra.
hello, sir.
I can hear you. Hello.
Okay, sir. It's a great session, and thanks to you and all, and mostly Shobhan sir and Existence Citizen Science Group. We learned many things today about astronomy.
Yes. Thank you, Rudra.
Good evening, sir. I am Shoujo, and it was
Hello,
very
Rudra.
yes, yeah. How are you?
Yeah, good. So how is everything
Yes, sir.
doing? Yeah.
Sir, well and good, sir. And it was a very informative session, sir.
Thank you. So you
Excited,
are in
sir.
class 6 right now or 7?
No,
right?
sir. 7, sir. 7.
7.
Yes.
Okay. That is nice. Go on.
And in the last session, the books that you have recommended, I have bought it and I am studying.
Oh, okay. That's nice. So actually, means this. So you are in 7. That means it proves that doing astronomy doesn't hamper studies, right? You are not failed.
Yes, sir. Of course.
Okay. Yeah. Okay. That is good. Thank you. Yeah.
Welcome, sir. Most welcome.
At present, are staying in Bangalore or Kolkata, sir?
At present, I am at home actually. So I submitted my thesis and came for some works here. Yeah, so I will have to go back to Bangalore for defense maybe after a few months. Yeah.
When you come to Bangalore, please kindly come to Bagalkot also. It is a night journey. We will meet, sir.
Yeah. Okay. Bagalkot is not very far from Bangalore, right? Yeah.
Yes, sir. One night journey, sir. Train is available.
Definitely we will meet. Yes. Definitely.
Thank you.
Yeah, sure. So Rishabh is come to Christ. Yeah, Rishabh, I will come to Christ. Yeah, I cannot leave Christ. Yeah, till now I am at Christ only. Yes. I will come. Definitely, I will come. Yeah. Okay, thank you, everybody. So if there is no question, then we can end up. And if any one of you have any question, you can actually put that question in chats also. We will be happy to answer.
Sir, I have a question.
Yeah, Rudra, tell me.
Sir, can I study aerospace engineering after higher secondary in India?
Can you study astronomy in higher secondary? Higher secondary, till now there is no option of studying astronomy because astronomy is a very specific field, right? So for that, understanding astronomy, you have to first know the basics of physics, chemistry, mathematics. That is why in higher secondary, well, the focus is on physics, mathematics, chemistry. But you can remain attached with these projects, citizen science projects, if you want to contribute, if you want to learn more about the subject. But if you want to formally want to know about the subject, you have to go to at least graduation level, because basic understanding of physics, chemistry, mathematics, these are necessary. Otherwise, the universe will become confusing to you. Yeah, this is why.
Okay, sir. I am a national campaigner at Bangladesh Physics Olympiad.
Okay, okay. So where are you from, Bangladesh? Which place?
Sir, I am from Khulna.
Khulna.
It's located in southern part of
Ah,
Bangladesh.
southern. Yeah, yeah, yeah. Nice, nice. That's nice. Yeah, so yeah, okay, okay. So Pritam Datta, sir, have you ever visited to Shiliguri? This is a nice question. Yes, so many times. Yes, so many times I have visited Shiliguri. I have also attended so many programs, given talks in different schools, including Shiliguri Boys High School, Girls High School, so many times. Yeah, so uh, definitely Bengali, staying in Bengal, never visited Shiliguri. That might not happen, I guess. Yes, definitely. Okay, also, there is a question from Himagno Ghosh. How can someone join ISRO? This is a good question. Himagno, yes, for joining ISRO, basically there are every year there are tests if there is vacancy. So these tests mainly comprises of engineering tests. So being an engineer, you can join ISRO if you can crack that test and interview. And engineering in specifically computer science, electronics, electrical, instrumentation, these are preferred. Yeah, electrical, these are preferred.
Sir,
Hello. Yeah, yeah.
sir, is it after BTech or after
After
MTech?
BTech also there are tests. Yeah, so there are tests, but these tests are not that every year it might happen. But if there are vacancies, they will take tests. And apart
Okay.
from that, I can also inform nowadays, presently from around 2007-8 onwards, there is this institute, Indian Institute of Space Science and Technology at Trivandrum. It is a
Hmm.
dedicated institute. It is funded, our level is funded by ISRO also. It is a dedicated institute for producing engineers and space scientists who can work for ISRO. So
Okay.
for joining that place, you have to get a very good rank in IIT Advanced. Yeah,
Okay.
very
Okay.
good. So
Okay.
if you have a very good rank at IIT Advanced, then you can join dual degree or BTech, MTech, integrated MTech. Like there are so many courses. There is a very unique course known as BTech in engineering physics and MS in astronomy astrophysics. So it's a dual degree course, BTech
Okay.
MS.
Okay.
So if you are joining that course, then
Thank you.
this is a direct kind of entry.
Thank you. Thank
Yeah,
Hello, sir. Sri
yeah,
Sunat.
yeah.
Sir,
Hello, hello.
I just want to know that you are completing PhD, right, from the Christian.
Yes,
So
yes,
can
yes.
I get to know about on what topic you are working? I am also PhD student at IIT Hyderabad in the Astro.
Oh, okay, okay. You're in IIT Hyderabad. Okay, I am
Yes.
working on emission line stars, optical spectroscopy of emission line stars, especially focusing on gaseous disks of BE type stars, B type
Oh,
emission line stars.
optical. Okay.
Optical spectroscopy, somewhat infrared, but majorly on optical spectroscopy. But I use majorly Indian facilities, all Indian facilities.
Wow. Okay,
Yes.
sir. Okay. Thank you.
Okay, okay. So in which year you are working now?
I am working with Dr. Mayuk Pahadi. I am third year right now.
Okay, you are in which topic you are working?
So I am working like black holes, how
Okay,
testing the general theory of relativity
okay.
around
Theoretical astro.
theoretical.
Okay, okay. That is good. That is good. Nice to meet you.
So
Yeah,
mine is in the X-ray mostly.
yeah. X-ray. Okay, okay. So you people use data from XMM Newton or other satellites?
Yeah, sure. Okay,
Definitely. Okay. Thank you. Thank you. Nice to
thank
meet
you,
you.
sir.
Yeah, yeah. Okay, yeah. So Rudra Pratap Nandi, have you ever come to Bangladesh? No, my friend, I haven't visited Bangladesh yet. And do you work with AstroSat, Pritam Datta? No, I especially do not work with AstroSat data, but we have our colleagues who are working with AstroSat data. Because my major focus is on optical spectroscopy of a particular type of stars. So that is not observable with AstroSat due to its limitations. Yeah, yeah. Yeah, I visit. Yeah. I have to visit Kolkata. Yeah. My house is in Kolkata. Yeah. So My house is in Damdam Park. Yeah, it's North Calcutta. Damdam people knows Damdam Park. Yeah, it's near Nagar Bazaar.
Sir, we also have a question from Siddharth Basu. Sir, I have proposed a project on the interrelationship between gravity, mass, and time, but I cannot understand how to solve the project. I'm a student of class 7.
Okay, I have proposed a project on the interrelationship between gravity, mass, and time, but I cannot understand how to start the project in Zoo universe. Siddharth, I would like to know means whether you have proposed to start this project, right?
Yes, sir.
Okay, but see, in that case, I feel you are too young to start a project at present in a Zooniverse platform. Because if you want to start a project, that means you are a team leader. You are starting a research project. Yes, so in that case, you have to have your own setup, everything. You have to have funding, money, own setup, a team of students who are working with you or under you on that particular topic. Then what are the problems you want to? Suppose in gravity, which problem you want to focus on, what you want to solve with that project. So suppose there is a project you might know that Galaxy Zoo, where people classify galaxies.
Mhm.
So if I see that, okay, I want to classify stars, so I am proposing a project, then I have to know which stars I should classify, which is not done previously. How will I get the data of the stars, right? I cannot just take a
Yes.
picture of the star, because that will not give data. Then I have to have the people who are looking after the computer systems, all managing everything, finance, manage economics, computers, office, everything you have to have. So this is a wonderful concept, and I am very much impressed that you, being a class 7 student, have an idea that I want to start my own project in Suniverse. But I will suggest that this is the time when you keep it reserved, learn about gravity, learn about physics, learn about astrophysics more and more, so that in future when you become an astronomer or you become a engineer and a good professional, then you can start the project. Because you need if you want to start an office, you need the office space, you need car,
Yes.
you need computer, you need electricity, so many things, right? At
Yes.
present you cannot do that, right? So this is the time when you should keep this idea with you, and this idea can become a wonderful idea one day in future. Yeah,
Okay.
keep it, yes, and go on studying, go on acquiring knowledge. Gradually other things will come. I'm very much impressed that at this age you are having an idea that I should start something on myself. That is wonderful.
Thank you, sir.
Thank you. Yeah. Okay. So Rudra Pratap Nandi, I am in 10th standard student. I want to study in India after my A level. I wish to study in aerospace engineering. Yes, Rudra, you can come to India. This is not a problem. There are so many good engineering colleges, including IITs, including I guess IIT Kanpur, IIT Roorkee. These all places are having, these are top places where aerospace engineering is offered. You can definitely come and join. And for that, if you want to come to IIT, you have to crack through IIT Joint, not the main, but the advanced level. So there are two levels. One is mains. If you crack mains, those who crack mains level, they can go and sit for advanced. You have to get a very good rank with advanced level. I will suggest that definitely hope and definitely target for the best places. That's why I am suggesting IITs. Yeah, there are also different other universities or colleges which are offering aerospace engineering, but definitely IITs will be the best. Yeah, so as you are in 10th standard, start preparing from today itself. Basic physics, maths, and chemistry. Then maybe after 2 years, you will be in a good position. If you can crack and you get a good position at IIT, you can definitely come. Yeah. Okay, Pritam Datta, sir, how is ResearchGate for sharing research? Yeah, definitely. We all researchers in astronomy, not only in astronomy, I feel in every area. Means it is mandatory to have a ResearchGate account. Yeah, definitely. If you have any research, if you have any research output, you can definitely share in ResearchGate, and that is hugely visible by the whole proper research community of the world. Yeah, so ResearchGate is a kind of ResearchGate is a means basic pitch for the players. A pitch is required, whoever you are, batsman, bowler, fielder. But if you don't have the pitch, then you cannot play, or the playground. So ResearchGate is like a playground where we play, which is very important for any researcher. I guess Sriman is there. She will also agree with me. She is also a researcher. So everybody is having a ResearchGate account, whoever is a researcher. Yeah. Okay, Shubhendupal, I want to make a citizen science group team in my school, but the students are thinking that it might be so tough that they cannot perform. Yeah, you can talk with Shobhan Babu and other people because they have helped in making so many good teams across India. Yes, definitely you can make a good team. Yeah. Pritam, you can connect with me in ResearchGate. Yes, I am in ResearchGate. You can connect. Yeah. So, okay, I can give my ResearchGate account, or I can give my ResearchGate here. This link here. So then you can connect with me. You can definitely connect. Yes. So, Pritam ji, this is my ResearchGate profile and link. You can connect. Yeah. Can you please suggest a book on black holes? Okay. So, Siddharth ji, if you are a young student, I will suggest one very good book, that is Black Holes by Jayanto Vishnu Narlikar, J.V. Narlikar. Black Holes. The name of the book is Black Holes. It's a small but very nice book, and it is published by National Book Trust. National Book Trust. I guess this book will be available in Amazon. If not, you can buy it from any good, means if you are in Bengal, you can buy it from any good book fair, or you can come to College Street. National Book Trust ka office is there, and you can buy it. It's very good book by J.V. Narlikar. Black Holes is for beginners, very beginners. But if it is available in Amazon or Flipkart, you can definitely buy it. So if you search in Amazon, just put Black Holes by J.V. Narlikar. So it should come if it is available. You can buy it and read it. Yeah, this is the.
Thank you, sir.
Okay, yeah. Or else you can come, তুমি এখানে এসে কলেজ স্ট্রিটের যাওয়ার পথে চিত্তরঞ্জন কলেজের পাশে ওদের অফিস আছে ন্যাশনাল বুক ট্রাস্টের, ওখান থেকে তুমি বইটা কিনতে পারো, or you can buy it from any good book fair, including Calcutta Book Fair. Go to the National Book Trust stall and buy it.
Okay, sir.
Yeah.
Sir, কলেজ স্ট্রিটে এটা কোন দোকানে পাবো?
কলেজ স্ট্রিট, তুমি যখন শিয়ালদাতের থেকে নেমে শিয়ালদার থেকে যখন কলেজ স্ট্রিটের দিকে যাচ্ছ, তখন ডান দিকে দেখবে পরপর মিত্র ইনস্টিটিউশন বলে একটা স্কুল আছে, সূর্য সেন স্ট্রিট। ওই সোজা এগিয়ে যাও, 61 MG রোড, 61 MG রোড, এই হচ্ছে ওদের অ্যাড্রেস। হ্যাঁ, খুব সুন্দর একটা কলেজ আছে, চিত্তরঞ্জন কলেজের মানে গলি আছে, একটা চিত্তরঞ্জন কলেজ, তার পাশের বাড়িটা ডান দিকে পড়বে। যদি তুমি শিয়ালদা থেকে টুয়ার্ডস কলেজ স্ট্রিট যাও এমজি রোড ধরে, 61 MG রোড, এই হচ্ছে ওদের অ্যাড্রেস। বা তুমি একবার ইন্টারনেটে জাস্ট লেখো ন্যাশনাল বুক ট্রাস্ট কলকাতা অ্যাড্রেস, বাস বেরিয়ে আসবে ওদের অ্যাড্রেসটা, একদম ডিরেকশন লোকেশন সব দিয়ে দেবে। ওকে রুদ্র, হ্যাঁ, ইউ ক্যান কন্ট্যাক্ট মি রুদ্র, ইউ ক্যান কন্ট্যাক্ট মি, সো আই ক্যান শেয়ার মাই WhatsApp number also. This is my WhatsApp number. Any one of you, if you want to like, you can contact me. And for India, +91, just add +91. This is my WhatsApp number. Anyone, if you like, you can contact me. And this is my WhatsApp number. Yeah. Yes, definitely. We all will meet someday in virtual, not virtually, physically. We will meet definitely. Yes, definitely. I guess we are ending the question answer also, right?
Yes, I think we don't have any more questions, so
Yes.
I think we can end our Q&A session here for today.
Yeah.
So before ending this session, thank you, sir. So before ending this session, I would like to say a few words about our upcoming events. So we will be launching 3 new sessions. First of all, we have our astrobiology masterclass, which will be starting on 26th of July this year, 26th, that is 26th of July 2023. And you can definitely enroll yourself for the astrobiology masterclass through the link that I have given in the chat. And this here you'll be taught by a few of the greatest minds of astrobiology, that is Anuj Soni and Yamini Tripathi. And if you are interested in terrestrial or extraterrestrial life forms and how astrobiology works and every details about astrobiology, if you're interested in that, definitely enroll yourself. I'm sure you'll be greatly helped from the sessions. Also, next month we'll be starting with the space technology training and internship program with Resolute Lab India, and we will be having a few of the greatest instructors for this session. We have an extra scientist, a few working professionals who will be teaching you, and also instructors from Resolute Lab India. And you'll not only taught about the theoretical part, you'll be also trained on the practical approach of everything. And you'll also work on a hands-on project at the end of this so that you can develop your practical approach and get ready for working in the industry. And also, we haven't declared the date of the last masterclass, our space law masterclass yet, but it will be starting soon. So it is a space law masterclass. So if you know about space law, you know that this is one of the growing sectors now, and any event or anything that you want to, any sort of events that you want to approach in the future, be it on space technology or any other sectors, you must know about space law and be well acquainted about the space laws. So this will be one of the greatest opportunities for you. So don't forget to enroll for this session also. So with that, I will be moving on to about ending this session. First of all, I want to thank Gourav sir for this wonderful session. I think this was one of the most detailed sessions we have ever done, and I'm sure all our participants have been greatly helped from this session, and I think they have learned a lot about what they can do currently in this in astronomy and citizen science, and also about what they can do in the future. And secondly, I would like to thank SS Citizen Science Group for helping us organizing this session. Without them, this wouldn't have been possible. So thank you, SS Citizen Science Group and Sovan sir. And lastly, I would like to thank all our participants for attending this session. Without all of you guys, this wouldn't have been a successful session. So thank you everyone for joining us and making this session engaging and entertaining. Thank you everyone.
Thank you sir for a good session and very informative session also. Thank you sir.
Thank you.
Thank you, sir. Stay well.
Stay
Thank you,
well.
sir.
Thank you.
Excellent presentation.
Well,
Okay, I'm sorry. Lastly, I'd like to request everyone to turn on their camera one so that we can take a picture. Thank you, everyone. With that, I think we can end our session here.